How is the situation of the pandemic in Indonesia, in your place?
It's actually, how should I say? I would say it's not quite controlled yet as compared to our neighbor country like Singapore. They already control the pandemic quite well, but our country's daily number is around 4,000 cases. So it's still quite dangerous actually. But a lot of people already have what recreational activity. They went to the beach, they went to have gatherings. It's already so common.
So the catering, I mean the enterprise activities is not controlled by the government. I mean, so restaurant.
Yeah, kind of, kind of like that. But it depends on ourselves. So if we can control ourselves, then we hope that we will be safe from this pandemic.
Okay, so the government doesn't really control the situation, but it's down to individuals, isn't it?
Now I think that is the case. Well, I'm afraid that it is recorded and the government will will kind of yeah, it's political issue in our country now. It's kind of political belief, who believes in the COVID and who doesn't believe. Some things that this is what what is that called, some propaganda from some country, something like that. Some beliefs like that. Okay, Ivan, let me check with Ivan. Are we ready to start? Or should we wait for a few more minutes?
I think I will wait for 1 minute. Yeah.
Okay, sure. Catherine
Hello,
is also
Ivan.
ready.
Hello, Dr. Hong Wei.
Yeah, hello. Yeah. So what I have already sent the slides to you. What I'm going to do is to introduce the university first, only using few slides to introduce the university and introduce the research activities in general for computer science department, and then come to the computer vision, applications of computer vision and pattern classification. Yeah.
Sure.
I will try to control the talk within, say, 50 to 1 hour. Yeah, this time.
Okay, that would be great. Okay, Ivan?
Okay, shall we start?
Yes.
Okay. Good evening, ladies and gentlemen. We would like to welcome Dr. Hong Wei of the University of Reading, United Kingdom. We are now continuing our meeting to the next agenda. That is, the lecture will be delivered by Dr. Hong Wei. This lecture will be moderated by Mrs. Risniati, MCS.
Ladies and gentlemen, please welcome Dr. Hong Wei and Mrs. Risniati. To the moderator, Mrs. Risniati, the stage is all yours.
Okay, thank you, Ivan and Catherine. The Honorable Vice Rector of Universitas Diponegoro, Professor Dr. Insinyur Ambarianto, Master of Science, the Honorable Dean of Faculty of Science and Mathematics, Professor Dr. Widowati, the Honorable Acting Head of Department of Informatics, Dr. Adi Wibowo, and also, of course, the Honorable our visiting professor from University of Reading, Dr. Hong Wei, and also fellow colleagues and students. Good afternoon. As has been introduced by the Master of Ceremony, my name is Rismi. I'm the lecturer from Department of Informatics, Universitas Diponegoro. And in this session, it is an honor for me to be the moderator for the second session of this visiting professor program. And before we start, let me or allow me to read through briefly the profile of our speaker for this second session. Our second session, just now, as you may seen, it is Dr. Hong Wei, or Associate Professor Hong Wei. She is currently lecturer at University of Reading. She's also currently in charge of Program Director of Bachelor of Science in Computer Science and Computer Science with Industrial Year, and also Program Director of Master of Science in Advanced Computer Science. She achieved her bachelor and master degree in Tianjin University, China, and then pursue her PhD in University of Birmingham. Currently, she is author or co-author of more than 60 referred research papers and also 2 textbooks. Her area of research interest currently including computer vision application in image analysis, pattern classification, remotely sensed data interpretation for environmental monitoring and precision agriculture, and also biometrics in automated border control. Okay, last but not least, before we start, for everyone who joined this lecture, feel free to type in your question during the session in the chat session if you have any question, or later during the Q&A session you can also raise your hand. Okay, without further ado, let us all welcome Dr. Hong Wei. Dr. Hong Wei, the stage is yours.
Okay, thank you, Rismi. I need to correct one thing. Probably,
Okay.
yes, I know you read the you
Profile.
quoted the profile from the website. Actually, the website hasn't really updated.
Oh,
I'm no
okay.
longer the director of the program for computer science. Yeah.
Okay, my apology for that.
Yeah, don't worry. Yeah, just to I don't want to do anymore because it's too much for me. I have done 8 years, so I get rid of that.
Okay, okay.
And put more time for the research. Okay, thank you. Good afternoon, everyone. It is my pleasure to deliver this lecture to you. So the title is Application of Computer Vision and the Pattern Classification. So my name is Hong Wei. I'm currently Associate Professor in the Department of Computer Science in the University of Reading, the United Kingdom. Okay, the contents of the presentation. I will start from the introduction to the University of Reading first, and a general introduction to the research area of computer vision, and then concentrate on my research, which is applications of computer vision and pattern classification in remotely sensed image understanding as well as biomatrix. And finally, I will introduce you a new idea. Well, when I said new, actually this idea in my mind for quite a long time, to explore technologies for improving old adults' living qualities. So that's the contents for today. Right. University of Reading actually used to be a college of Reading, established as an extension of the Christ Church College of the University of Oxford back to 1892. So it's have a long history. In 1926, the college becomes to the University of Reading. So we nearly have 100 years history. So in 6 years' time, we actually have 100 anniversary celebration. We always claim ourselves as a world-class reputation for teaching, research, and enterprise. We ranked at 35th in the UK for the quality of its research and the 28th for its research power in the 2014 Research Excellence Framework. In the United Kingdom, actually every 6 years or every 6 or 7 years, the government will run RAF. We said it's Research Excellence Framework. So the last one was in 2014, and the next one will be in the next year. So we are very busy doing the RAF return at the moment. Okay, where we are, I don't know if you are familiar with the shape or geography of United Kingdom. So we are very close to London, about 40 miles west to London. So located in Royal County of Berkshire at the heart of the Thames Valley on the M4 corridor. So this actually is referred as Silicon Valley of Europe. So you may have already heard Silicon Valley in the States. So in California, San Jose, and in the M4 corridor, actually, this area is referred as Silicon Valley of Europe. Later, you will see how many big IT firms are here. because it's only 40 miles west to London. So if you take trees, only take 30 minutes, you can arrive to London, and 40 minutes from Heathrow Airport by bus. Okay, let's see the Thames Valley Park at Reading and the M4 corridor. M4 is a motorway, so M4 motorway. So along the motorway, there are Reading, Marlow, Slough, Newbury, and Sweden, Bracknell. And here can you see the cursor moving? Yeah.
Yes, I can see
Okay,
the cursor.
so if you look at it here, it's Reading, Bracknell, those are city or areas. You can see in Reading, we have Microsoft European headquarter, have Huawei, NVIDIA, Oracle, Cisco, all those big firms have their headquarter in Reading. Reading is the town where University of Reading located, and very close to here is Bracknell. And you can see many companies, big IT international firms in the M4 corridor. Okay, we have 3 campuses in Reading. The main one is White Knight campus. It's a hub of campus life for most students. Accommodate most department and schools in White Knight campus. Another one is London Road. There is a great hall. We have our graduate ceremony and other activities there. And that campus also accommodate Institute of Education. The other one is quite far away from the main campus. It's mainly for business school, Hanley Business School. Hanley Business School joined the University of Reading in 28. Actually, the university bought Hanley Business School and as part of the university. Okay, we always said we are very proud of the world-class environment. Over the past 10 years, we have invested over 400 million pounds into our teaching, research, and living facilities. And if you come to the university, you will see, certainly we have some old buildings. The Reading campus, the White Knight campus, used to belong to a rich family. So the family donated their properties to the government, and the government actually gave the property to Reading University and established the campus. There are old buildings, but also you can see some new buildings built recent years. So it's the university investment. There are world-class facilities for teaching and research, as well as living. So inside campus, there are so many halls which accommodates students. So students can live in halls and only have very short distance walk to the lecture theaters, to library, and to research labs. Yeah, another thing I would like to say is White Knights campuses have been awarded one of the best green spaces in the country since 2011. So you are very welcome to visit us in your convenient time, or even join us to study in the University of Reading. You will see enjoying the beautiful campus. It's like a park. It's very nice environment. Okay. Department of Computer Science. Here we have 3 research groups, Data Science and Artificial Intelligence Research Group. So develop algorithms, tools, and applications for machine learning, data mining, and big data analytics, and predictive and descriptive analytics, and all sorts of applications in the big data field, application in many different areas, industry and business sectors. And another research group is called Computational Vision Group. It's the group I am in. So we do image processing and computer vision, automated CCTV analysis for safety, security, and surveillance, right? Biomatrix and the environment monitoring, people and vehicle surveillance, all sort of applications are conducted in the, we said is CVG, Computational Vision Group. So that's the activity. I will go through the details for our Computational Vision Group research. The final one is Advanced Computing for Environment Science. This research group and is a joint group with Department of Meteorology, as well as ECMRWF, UK Met Office, mainly for big data for environment science and scientific programming software for next generation supercomputing and the data systems. So that's the three groups, research group. So from the three research group, you can roughly see the profile of our research in the department. Yeah, here I give you some examples of computer vision applications in the department. For example, we have automated border control, airport gate recognition. So you must have already had this experience when you try to go through the border control in airport or in the land border control. You need to use your passport. In nowadays, many airports actually have the face recognition system or fingerprint recognition system as identity recognition. So actually our group is active, very active research, have very active research in this area for biometric solutions for automated passenger identification. For example, face, fingerprint, iris recognition, and counter spoofing. Yeah, counter spoofing is one thing we have done for a European project. So I will come to this point later because I'm part of the project. CCTV video analysis for surveillance and security. University of Reading, the CVG, the Computational Vision Group, actually is a pioneer in CCTV surveillance back to last century, early 1990, I think, we established the research group doing research in CCTV surveillance. And currently, our work mainly focuses on airport surveillance, border security, maritime surveillance, as well as environment surveillance. So I haven't put that one. Environment surveillance is something we are currently working on. Another European project, Horizon 2020 project, in collaboration with vendors, research institutions, and the UK Home Office, is called Protect. Protect actually is project try to establish airport border control by using artificial intelligence facilities or mechanisms. Currently is undergoing. Okay, computer vision, I heard from Rasmi, actually all of you come from the group study computer vision. So you must have already know what is computer vision. Here I give you some summary. Computer vision, also named as machine vision, refers to the technology by which a computer associated with cameras can emulate the human vision system to see the world. As we have known, for the human vision system, we use our eyes to capture information, right? So as an image, and our brain will try to interpret the image and give us the information. For example, is this the tree, is the sky, or is the building? Computer vision cameras are used to replace, let's say, focus our eyes, capture image in, and then input the image into computer. The computer will work as the brain, do all sort of things our brain need to do. For example, the problem now is we don't exactly know how our brain does to interpret in the cognitive side, how our brain does to recognize or understand the environment. Yes, we know something, but not all, not everything. So that's why from computer vision point of view, we do have the obstacle to develop our algorithms to emulate human vision system. Yeah, one thing we know is learning, right? So we understand things, human being understand the world by learning. So machine learning becomes to something which we cannot bypass when we do the computer vision research. Okay, here, many people actually confused by computer vision, machine learning, and artificial intelligence. So here, based my understanding, I draw this simple figure to show the relationships between artificial intelligence, machine learning, computer vision, now deep learning, right? Deep learning become very popular in our community because it's powerful, because it's power in pattern recognition. Okay, so artificial intelligence is a large area. Machine learning and the computer vision actually are two individual domains sit inside artificial intelligence. Machine learning and computer vision have overlap. Yeah, actually, at the end of the cognitive side, so when the image is captured into for the computer vision system, when image is captured into the system, but how to understand the image, we need to have the learning, for example, first of all, to process the image, to enhance the image quality, and to extract the features, to represent object which we are interested, and then to present those to the machine, right? And the machine can start learn those through the training process. So from this from this point, actually, machine learning and computer vision is overlapping. Yeah, deep learning is something, is a branch actually inside machine learning. Yeah, that's the deep learning. It's a branch inside machine learning. Again, it's overlap with computer vision. If you look at the conference paper or journal paper recent years, I think start from 2014 or 2015, the papers for deep learning application in computer vision becomes very popular. Many people are working in this area, try to adapt deep learning tools in computer vision and enhance the computer vision the powers. Basically, computer vision finally will becomes to pattern recognition, the recognition rate, classification, object classification, the classification accuracy. So the deep learning actually can provide us much better result compared to the conventional machine learning methods in many cases, but not all. Right. Yeah. Artificial intelligence actually is much larger area. For example, could include many other area: neuroscience, social science, biomedical science, or biologic science. So let's establish these big pictures, especially for those people from other area, from computer science, from engineering, computer science. It seems it's better for us to understand the picture. But from other areas, 1 year, I think 2 years ago, I delivered a presentation talk to the UK government workshop. Actually, that workshop is, the participant is from agricultural, from environment sectors. So it seems it's quite confusing for them. What is artificial intelligence? What is machine learning and the computer vision? But I hope all the audience today are quite familiar with the relationships. It's only my understanding. If you think it's not correct, you can always adjust it or put your answers to this picture. Okay, now I think it's the time for me to introduce my research, remotely sensed image understanding, include automatic land cover classification. We start from conventional method or approach to deep convolution neural network approach, and image registration for terrain reconstruction of moon surface for robot landing. Yeah, here the first example is separation of residential area, river, and green land. When we have the remote sensed image, how to develop algorithms which can help us to segment the images to identify residential area, river, and the green area. So we developed unsupervised segmentation algorithms using Gabor features to identify residential areas. I don't know, have you learned the relevant techniques or not? Gabor wavelets actually can provide us a tool to extract features from images where there is a silhouette change. For example, you can define a set of Gabor filters. After this operation, Gabor filter operation basically is convolution. So we can it can help us to extract the high frequency part. In this case, actually, all high frequency part is component is identified. So those high frequency components represent the residential area. So we use some other statistic method to highlight the residential area. For example, in this case, it's the red in the first example. Yeah, it's the red area, and then blue is river, water, and then green is the green land. The next example is the tree detection. We use Tempest Shuffle evidence theory. It's a kind of algorithm. And apply LiDAR first echo, last echo, and co-registered RGB and near-infrared images to detect trees in urban area. So here we used Tempest Shuffle evidence theory. The data we have is LiDAR data. LiDAR is a laser scanned data. So FE here is the first echo, and LE here is the last echo. First echo and the last echo actually give us the height information. So we will have the distance information. And we also have RGB image information, pictures. Apart from that, we have the near-infrared images. So based on the given data, apply the Tempest Shuffle evidence theory to the data, we can identify the trees and then to highlight the crown of trees. So this is very important for the environmental scientists used for their model, for example, to identify the air pollution situation or identify other situations in the urban area. For LiDAR, airborne LiDAR, we also use airborne LiDAR and co-registered band, for example, RGB and near-infrared for the land cover classification. Yeah, hierarchical framework for urban area land cover classification. This is a data-driven combination framework. The data used is HD. HD actually is height difference. Height difference is from first echo and the last echo to take the data from first echo by last echo. Basically, I don't know how many of you know the LiDAR data. LiDAR data can actually is the laser scan. When laser touch the object on the surface, will return a point back to the sensor, and that will give by using the time span, we can calculate the distance. One property for LiDAR sensor is LiDAR can penetrate vegetation. For example, that's why we can use LiDAR data to identify the tree crown. Yeah. So take the last echo from the first echo, we can find the height difference between trees, right? If this is a solid surface, there is no last echo. There is only one first echo. Another, yes, here, as you can see, it's NDVI is a normalized difference of vegetation index. So this is specifically used for vegetation identification. So here we have 4 classes. We used to have 5 classes. Here we list 4 classes: building, grass, road, and tree. The 5th class is cars or vehicles. Finally, we found it's not accurate at all. We took that out. Fuzzy probability mass functions were developed in Tempest-Shuffle evidence theory. So again, Tempest-Shuffle evidence theory is used. If you look at the workflow, you will find, Tempest-Shuffle evidence theory is also applied in this piece of work. It is unsupervised classification. The only information we used is the priori knowledge. For example, the height of the tree. We know the tree is higher than the ground, right? And the building is higher than the ground. So that's the information we used. There is no training sample. No training sample needed. So for the remote sensed data, try to work on remote sensed data and identify for example, for the land cover classification, unsupervised algorithms or techniques is much more desirable. Right, that is because it's not always easy to find the training data. Okay, we also tried deep convolution neural network in land cover classification. We use semantic segmentation. Some of you may have already used it or learned it. There are so many existing platforms help us to do the semantic segmentation. So deep convolution neural network are employed. We tried various models. 4 models are attempted on ISPRS benchmark data sets. So in this data set, we will provide RGB image as well as near-infrared image. So we did not use the height information, LiDAR data, only used RGB image and near-infrared. Interestingly, compared to the conventional methods, the car class received a relatively high classification accuracy. This is very interesting to me. So when I observed this, which actually is quite not shock, but quite give me quite large impact. So because no matter what we tried, by using the conventional method to extract features and by using Tempest-Shuffle evidence theory, we couldn't get high recognition accuracy for the car classes. However, by using the deep learning method, semantic segmentation method, actually the car class appears equivalent classification accuracy as building, tree, road, and other classes. So this is very interesting. So far, I don't have answers to this phenomena or observation, but myself and my PhD student are working on this and try to find the reasons behind this. If you do have the answers, please do let me know. Okay, the next one is remote sensing application. We also did other applications, for example, monitoring crop growth, segmentation of Golfin 1 satellite images to identify crop areas for precision yield prediction. So that belongs to precision agriculture. I think Retinol had this proposal, doing the precision agriculture by using remote sensed data. I think that's also a large area where we can explore. Try to use the tons and tons remote sensed data and service for the precision agriculture. Convolution neural network also applied in this project. However, unfortunately, did not give us significant advantages compared to the conventional methods. Yeah, 3D reconstruction from accurate image pixel registration. We did some research on image registration. The aim is to reconstruct the 3D surface of moons to help the moon landing. Yeah, we developed a 4-step advanced SIFT based local registration method for satellite images. The image we have is from Chang E2. So that's another 2 projects. Okay, so we also did some work in Biomatrix, for example, anti-spoofing in face recognition, keystroke dynamics, authentication, and the gate representation in gate recognition. Yeah, let's first see the anti-spoofing in face. We all know we use the face to going through the border control, right? However, sometimes some people using the spoofing face, for example, they print other people's face and use the printed face to cheat the face recognition system. So in this project, we did research to develop algorithms which can identify the spoofing faces. If in case someone using the spoofing faces to try to cheat the face recognition system, the algorithm can identify this. Here we used 2 different types of spoofing face. One is paper mask, another is screen display. So some people use the spoofing face and print it in the on face, and that's one spoofing face, one type of spoofing face. Another is display the face on the iPad screen. What we do is using polarization imaging to identify. So in this, we use the physical method as a lighting to capture image. And after that, we analyze the images captured by the camera and then develop algorithms to identify the spoofing face. So here, polarization imaging is exploited with other image features in spoofing detection, and the Stokes degree of linear polarization is parameter is used as the measurement as measures. So as you can see from the screen, the first line, top is the we set is SD DOLP images. So after the image is captured, and we convert or transform the image by using Stokes' degree of linear polarization to represent the image. First is the real image. The second is the paper image or spoofing image by using paper mask. And the last row is the spoofing image by screen display. You can see clearly the difference, right? So based on the fact, what we do is to develop statistic methods to distinguish between the real image and the spoofing image. Actually, that gave us very high recognition rate to identify the spoofing basis. As we can see, for the screen display, there is no problem because the intensity is very high. For the paper and real face, we can still see the difference, right? Okay. Free text keystroke dynamic authentication try to use the way people use the keyboard to identify it's A or B or C. So to identify individuals. First of all, we need to formation of features. A large set of timing features and the non-conventional features are established. So in this project, we published a few papers. And also optimization for feature subset selection were conducted. So based on the large set of features and which feature are representative, we use optimization method to do the feature selection. And also we do the feature level and the decision level fusions to improve the recognition rate. Right. The final one is the gait representations in gait recognition. We use gait to identify individuals. So this actually is quite popular research in the biometric community, because gait, we all know gait have advantages. If you use face, use print, use fingerprint, use iris, you always need the cooperation of the users, right? So without the cooperation of users, actually, we cannot really capture the images or high quality images. But gait, we can use the long distance to capture the image or capture the video sequence and do the identification. It's quite challenging. However, many people are doing research in this area and try to take this in practice. So in this research, actually, we concentrate on gait representations. So which part of the gait more representative to the real pattern? We combined partial body investigation. Yeah, for example, we split the body parts into, say, 15 body parts, and which part is more representative to represent individuals. And also developed some mathematic functions to represent after the gait images is captured, and how to use different features to represent the gait images, a combination of partial bodies to improve the recognition rate. So that's something we did in this project. We don't have conclusion, but we do have some observations. For example, some parts of the body good for the recognition. However, if the person wear clothes, especially the long coat, the method doesn't work. Something like this. We have many observations generated from the research. Okay, finally, I think the time is almost due. Finally, I would like to introduce one of the, actually it's a PhD project, which is an idea in my mind for a long time. exploration of technologies to improve old elder adults' living quality. So we have technology developed, and we are talking about artificial intelligence, computer vision, machine learning, but how to use those technologies to help old people to improve their living quality. And in this project, we use the connector-based facility to develop games. We said it's EXA game. Yeah, as you can see, it's EXA game. Can I have annotation? Yeah. Yeah, and EXA game. Develop EXA games. Yeah, the sensor is Connect. I'm sure all of you know Connect, which is used to be Microsoft products, and now I think Microsoft is get rid of it, but the products itself still developing. The aim is to address sedentary behaviors of old adults. So if we can develop, the idea is if we can develop very interesting games and as a products, and when those old adults can use the products to do the exercises or just play with the game, that may, if they're interested to do that, so can prevent them from sedentary behaviors. Yeah, so that's the purpose. Yeah, sedentary behavior. So that's the purpose of the project. So what we do is first develop a very simple but fun. First of all, actually, what we developed is different interfaces of the game to see what kind of interface old adults or old people more interested from female, male, also different ethical backgrounds. And then developed a very simple game, EXO games, and we invite the participants. All participants need to be over age 65, and then can move to play with the EXO game. And after 3 months, we do some tests, include physical and cognitive tests, to check if their moving performance or cognitive performance improved. So that's a very preliminary research at this moment. So if you are interested, very welcome to join the research. I think we do need to do something, try to use the advanced technology to help the aging community. It's not moving anymore. How to mouse? Okay, I think that's all. Thank you. Thank you for your listening.
Okay.
Any questions? Yeah.
Yeah. There is very interesting topics that you have delivered to us. It's a lot of research topics that actually we can work on also. Okay. Maybe we have some question. Yeah, we have a question. First question. Okay, we encourage everyone to type questions because we will also have special door prize for those who are lucky. From our department, we will have some gift to those who post a question. Okay, first question is from Fatah Muria here in the chat. What is
in the chat?
Yeah, can you? Yeah, I can read for you, or you can.
I'm going to go to the chat. How to go to the chat?
Below the screen there is.
Oh yes, it's here.
Yeah. First question is from Fatah Muria. This one. What's the future for face recognition? Is there any room for improvement on the side of algorithm?
Yes.
I mean, yeah.
I still couldn't find the note board. What is the? If I can see the question, that would be.
Okay. Can you see the question?
Let me clear this one. More. Remote control participant security stop.
No, it's on the chat.
On chat.
Beside participants, there's a chat.
Oh, no.
Can you see that?
Oh. Below participant, there is a chat.
Not below, right in the right side of the participants in my screen. I hope it is the same setting.
Where is that?
Yeah, besides share screen, just now we have share
Sorry
screen.
for this, because I never use Zoom.
Zoom.
I never use Zoom before. We always use Team.
Yeah.
Oh, no.
Usually we also use Teams, but in this special occasion we use Zoom.
Oh, don't worry. Just you, if you can read it to me,
Okay. I will try to read for you. Okay, from Fatah Muria, what is the future for face recognition? Is there any room for improvement on the side of algorithm? He means that can we extract information from blurry image? Let me rephrase the last sentence. I mean, we can extract information from blurry image, can we? If we have blurry image, can we extract the information from this type of image?
The feature, actually, there are so many features, and people working in this area for such long time. There is a book, it's called a texture feature application or image texture feature, published in, I think, in Cambridge publishers, listed 48 types of different features which we could use. In our case, actually, we tried Gabo feature, LBP, many other features. So almost tried all texture features which we could use. However, if you ask which features is best, are there spaces to develop more features or to improve? Yes, I would certainly think so. Yeah, one thing I think in the image analysis, or when we try to extract the features, and sometimes it's aimless. Yeah, we try different things, but why do we try that? Seems not to have much foundation, say, because the Gabo wavelets can give us a set of the frequency. Therefore, we can choose the frequency and then to extract the information which we are interested. Yeah, that's one thing we could say. But in fact, my experience is people try different features. However, why did people try those features? There is no much reason behind. In nowadays, actually, people don't use features. They threw the raw data into the deep learning neural network and then to generate a set of features which we don't know what it is. And some people also try to understand the meaning of those features and try, for example, I understand, okay, this group of features represent color, that group of features represent, say, shape or something. But actually, it's in very, very beginning of the research. I haven't really seen any meaningful result published.
Okay.
Is that to answer the question?
In some way, yes, it is. So, if let's say we were talking about the future for face recognition, is it more towards deep learning or is it more towards exploration of the feature that is available from the image itself? What do you think?
Yes, I have done research in this area for many years. Before 2015, we were all concentrated on convention method, try to extract the features, and then choose the classifiers to do the understanding or cognition, recognition. However, after 2015, people seems all come to the deep learning area and try to use the deep neural network help us to extract the features. My experience is actually by using the black box, we have very limited space for research unless you go inside to the box and do some modification or from optimization point of view to changing the neural network. Otherwise, from a computer vision or image analysis point of view, I wouldn't think there is much space for us for research. If you can still come back to the image analysis and try to explore features, certainly is some area which quite attractive.
Yeah, I think also currently I'm also start doing deep learning and transfer learning. It's quite interesting also recently. Okay, just now I have information from one of the audience. If you want to open the chat, maybe you may press Alt plus H, Alt H together.
LTH.
Yeah, yes.
Okay. Press LTH from
the Zoom. Does it show the chat session in your screen?
What they said, press Alt plus H from resume to everyone. Thank you. From
yes. Also, there is the so you can
pattern recognition. Oh yes, I can see. Can pattern recognition with can pattern recognition with face detection help identify people who have a disease such as COVID? You can imagine, I couldn't really answer the question because I haven't really done anything in this aspect.
For the COVID-19
However, you can imagine pattern recognition or if face detection or image-based pattern recognition is just purely based on appearance. If, for example, COVID-19 patient have a change of appearance, yes, why not? Yeah, it's just based on appearance. If appearance change, and your algorithm can identify those change by using all sorts of features, yes, I would think so.
Okay. Does it mean that if human can differentiate between COVID-19 patient and non-COVID-19 patient, then the computer should be able? And if human cannot, then computer cannot? Does that mean like that?
If human cannot, doesn't mean computer cannot. That is, for example, face recognition. Computer does much better job than human. Yeah, in one of the project which we used, actually we did test in Finland, in Helsinki's airport. Human can only recognize the faces about 30 to 70%. I mean, to identify the differentiation of two persons, but machine can do this very simply. Only simple algorithm can achieve, say, 80% accuracy. So sometimes machine is better than human, but the problem is this: machine does work different from we do the work. That's the issue. If we can identify difference, can machine identify difference? The answer is probably not, because machine doesn't know how we identify the difference. Yeah, that's my my answer. The problem again is back to the original issue. We don't really understand how we see the world. If we totally understand how humans see the world, probably we can develop algorithms to simulate the process and make machine to be able to see the world like we see the world.
Okay, that is interesting. Okay, we have next question from Bernardinus Hendrana tadi. Is it possible to use gait recognition to detect or prevent mischievous activities such as potential bank robbery or terrorism?
is what you write here to do computer vision task. Are they ready yet? What I can see from, probably I need to, if you can slide, I don't have control to the, do I can, yes, I do have control, Can pattern recognition with face detection help identify? The next one.
Next one.
Is it possible to use gait recognition to? I think so. Yeah. Yes, I think so. If it's mature, the problem now is it's not mature yet. You can imagine by using gait or all sort of classification or detection identification things, we based on the training sample, right? If we have a reliable training sample which can represent all possibilities of those robbery and terrorism, yes, I think gait recognition certainly is a good way to do the job. However, if you think about the variance of those people, the robbery or terrorism, are there patterns? Can we capture the patterns? Yeah, that's something we need to ask.
Okay.
Is this answer your question?
I think it answered the question.
And what do you think
about deep learning? I think simple machine learning algorithm.
No, never. I wouldn't think. I wouldn't think deep learning approach will replace the simple machine learning algorithm. No, never. You can imagine deep learning actually is purely depends on the training data. Without a large amount of training data, deep learning doesn't work, doesn't show the superior or beneficial. We have tried this in quite a few applications. Actually, for those cases where we couldn't have large training samples, deep learning doesn't really help, and even have worse result.
When we say large, how many
how large
images?
Is large?
How large is large in this case?
No one gave us very clear answer to this, and also depends on your network. The network, back to the curse of the dimensionality. So we need to take those two aspects into account.
Okay. Because he have heard that Viola Jones algorithm did face detection a lot faster than deep learning. With very high accuracy. Okay.
Yes,
I think it answered the question.
Viola Jones, I think, is such popular and also powerful face detection algorithm, which used almost for all commercial face detection cameras, right? So for face detection, I think Viola Jones algorithm still the most popular algorithm used in nowadays.
Okay. So
because it's simple and fast.
Okay. The next question from Yasir Abdurrahman. How to handle racial bias in face recognition? Should we just optimize our model or method, or should we improve our data sets?
Data sets certainly is something I always think. Data sets is our original tool to train the machine. So if you can use ideal data sets, certainly will help you to establish reliable model. So that's my understanding. The bias situation is always there. Some algorithms, for example, if you use the SVM, probably can partially deal with the bias situation. The bias, or you mean the racial bias? I haven't done research in this aspect. Actually, in the spoofing research, we did find people with black skin, actually it's easier to spoof in the system. That is because the method we used, the polarization method, doesn't work very well to the black skin. But I couldn't really answer this question very well because we haven't done systematic research on this topic. If you are talking about the sample balance, some classification methods actually deal with the sample balance. For example, SVM can partially deal with the sample balance. Does that answer the question?
I think it answered the question.
Yeah.
I think.
Basically, I cannot answer the question, but if it's the sample balance, yes.
Later, maybe Mr. Yasir can clarify the question. I think in this case, racial bias also caused by in face recognition, especially, is also caused by the number of sample which is not balanced between the majority and minority in the training data itself. I think maybe that is what he's trying to ask, but maybe later he can clarify in the chat also.
Yeah. Again, racial bias. I mean, depends the feature you used. To be honest, for example, if you use Gabor feature, which only give you the silhouette change, doesn't really mind the ratios. I don't think the
Color,
color matters a lot. However, the case which we used in the spoofing phase, we did not extract any features. We used the images from the polarized light, and with polarization light, polarized light, when we capture the image, we convert the image into stock space and use the stock parameters to represent the image. So it's the full image rather than the features. If you extract the features, already exclude the color information or other, I wouldn't think racial or will be something. But sorry, I shouldn't really say this because I never done the research in this aspect.
Okay. Maybe we can move to the next question. We have Ivan Benawan here. How to deal with overfitting in computer vision? Because in his case, he got very low loss in training, but still very high loss in validation loss.
Yeah, let's say in this way, I don't have immediately answer to this. That is because my research is very limited into the high level, haven't go to the low level to do the optimization and control the loss, etc. However, my understanding is this: if you have large training samples, you will less worry about the overfitting. However, if you only have very limited training sample, yes, you do need to take this into account. For some and also to choose the classification methods. Some classifiers may deal with this well, but some classifiers may not. So that's something you need to really take into account. So when you set loss or is which classifiers do you refer to? For the binary tree, for the decision tree, actually, you do not have this problem, right?
Yeah, I think it needs to be clarified also how many training data that he used. Maybe Mr. Ivan can also elaborate this question from his research later on. Okay, maybe we can move on. First, we still have time. Do you still have time to answer some more questions? We have.
Yes, okay.
Yeah. Okay, we have a few more questions here.
Can
Can
anti-spoofing?
Yeah.
Yes, a very interesting question. for the finally we did use the mask. Actually, we ordered some silicon mask from a company and try to LBP is very good to identify the details. If you use different materials, and also the polarization lights, because polarization lights can identify the detailed surface change. Therefore, if you use different materials, that do reflect to the captured images. Yeah, we haven't really done much experiment because we only ordered a few masks. We already noticed it is, yes, the algorithm we developed can identify different materials.
Okay, that is impressive. Okay, we have 3 more questions here. I hope we still have enough time. Computer vision using camera to detect people, so it might be a violation to the privacy right. Okay. So with the future of computer vision that can be implemented in everywhere, will it cause the privacy right or everyone's privacy right?
Yeah, this is something so many people are concerned and doing research from ethical and from social legal part to do the research. I haven't done anything in this aspect, but certainly I'm aware of the privacy and the social legal ethical issues introduced by face recognition or face detection. This has to be enforced by law, I think. We cannot just leave it without control. Yeah, so that's my answer to this question.
Okay. So it needs to be controlled by the government
by law.
itself, by law.
By law, yeah, I think definitely need to enforce it by law and try not to stop people abusing this.
Okay. This one also almost similar question. Any concern that humanity heading to dystopian future where all human beings are being monitored? I'm not sure.
Many concerns. I'm as I have been aware of, there are large of number of researchers doing research in this aspect. One of my colleagues actually doing research, but now he left the UK, moved to Japan, but continue doing research in this aspect, how to establish from a law enforcement point of view, how to make the not only face recognition, actually IT as whole, to be controlled or to be under monitored. Yeah, that's my answer to that question. Yeah.
Okay. Now, there's this one should be last question, but Bernardi must just now clarify his question. Is there any computer vision problem that cannot be solved yet due to our computational limitation?
Oh, many. You can see many. So I didn't know it's because due to the computation limitation or due to our understand to our human vision system. That's why if we are thinking the definition of computer vision is to replace the human vision to see the world, I have less concerned to computation limitation rather than the understanding of the human vision system. Since we didn't really understand the human vision system, therefore, the computer vision hasn't really gone very far. Back to a few years ago, computation cost is a very significant issue. But in nowadays, I wouldn't think computation limitation becomes to an obstacle for using computer vision in the real world. But it's still not that popular because of we cannot really by using computers to replace human vision to see the world because of we don't understand the human vision itself. We can only do very limited work. Yeah.
Okay. Maybe this one is just to elaborate the question delivered by. Okay. Is it possible to fool the algorithm just now by using material that is close to the human skin? The question about the spoofing, am I right?
Yeah.
Yeah.
I think it is possible. Yeah, it is possible. However, since our experiment is very limited to few materials, and we noticed our method by using polarization light and extract stock parameters is very significant to identify different materials. Certainly, if you ask me, is that possible to find a material which have similar properties with human skin? I would say it's possible. There must be some material which very similar to the property of human skin.
Okay.
Yeah.
This one is very special question. I have a
Mm-hmm.
very special question from
Mm-hmm.
Dr. Retno because currently she's still holding her baby.
Mm-hmm.
Special or she sent her best regards to you. Okay, she's asking about your Kinect project just now, the games. Am I, if I'm not mistaken, for that game, uh, is it possible? Okay, let me read through again the question. Okay, for the
Oh,
game that
that's
you
very
have,
interesting.
yeah,
Someone Fieza or
the,
Leah said computer vision and machine vision. Actually, well, I agree with you, Faziza. In this presentation, I said in general, we said computer vision and the machine vision, they are, yeah, doing similar things. But in the community, actually, there are arguments for such a long time. Even now, we don't have clear identification or definition to computer vision and the machine vision. What is the differentiation between them? Here, actually, Fia, yeah, let me see. Fiaza gives some differentiation between machine vision and they said topics that there is difference between computer vision and machine vision, such a machine vision as a body system and computer vision as a retina. So I want to ask, if you asked me, I wouldn't think it's true. My opinion is, in general, in the high level, machine vision is computer vision. If you try to go into the details, what is machine vision? I haven't seen any authorized definition say what is computer vision or machine vision. You may like to explore more, but from my understanding, I treat machine vision and the computer vision as similar thing. They are doing similar thing.
okay.
Mm-hmm.
Okay, just now let me continue the question from
Mm-hmm.
Dr. Retno. Okay, for the games that you have developed for the Kinect project just now, is it applicable to all races? For example, like for European and for Indonesian, will it be applicable your games, or can we
Yes,
develop different models
there
for
there is
different?
there is no when we develop it's a PhD project. When we develop the games, we didn't take individual into account. It's a game everyone can play. Actually, the developer, the PhD student is from Saudi. So in the course of doing the project, actually we noticed from different ethical group, people may reflect different views to this type of game. We said it's an EXA game. So that is one research idea in my mind. Probably we can do a little research to see how different ethical groups, adults or old adults, to have views towards this type of exercises. So probably only suitable for one ethical group, and another ethical group, because they have already had many relatives or many activities around, they don't really need that.
Okay.
But from game point of view, there is no difference. There is no differentiations towards a different ethical group.
Okay. So it means that let's say if we were to conduct research for especially for Indonesian, it more or less would be the same with the model that developed for the
I would be
European.
very interesting to see the result. I don't
Oh,
know, but yeah, I did. What I can imagine is some ethical group, for example, the old adults, they are not lonely. They can go outside, talk to relatives, talk to various peoples, and have very busy life, even in the old age. But for Western, especially in the UK, the Asian community becomes too very large. However, many people live alone and without people surrounding. So this type of activities or extra games probably more meaningful to them. So that's my understanding or my imagination.
okay. I hope that answer Dr. Retno's question, who is
Yeah.
currently unable to join us. Okay. Last but not least, I would like to ask question for maybe not question, but maybe I would like to have your suggestion for us and also for our students, maybe who who are very interested in computer vision. As a starter, where should the research in computer vision goes? Is it better go to the classical computer vision first, the feature extraction process, or is it better that they explore the deep learning process as it gives usually better result? What do you think? What is your suggestion?
What I think, yeah, if look at my journey to in this area, we start from image analysis actually, because images is our original source. Let's say it's our original source, and try to extract the information from images. That's one aspect to do image analysis, and try to extract as much information as possible to help your understanding or interpretation. I think it's still large area. However, if you think about image, we have color image, we have height information, we have many, but how to make use of the information becomes to something. I think still have space for exploration. That's one thing. And also the moving video sequence and how to use video, the moving information to extract something you are interested. That's for this side. For deep learning, I think deep learning certainly is a very potential area, which I don't know much yet. Since, say, 2015, we start our research in this area, and little by little, and we try to understand the inside. But again, I don't many things I don't understand. I need to explore more. One thing I think for deep learning, if, for example, deep learning can combine with the neuroscience and provide some information to the neuroscience and explore how we see the world from a human vision system point of view to understand how we see the world. That is something big, significant contribution, I think. But how difficult it is, I don't know.
Okay.
Yeah.
I think that should conclude the Q&A session because I
Okay.
think we are also running out of time also. Okay.
Okay.
Thank
Yeah.
you very much, Dr. Hongwei, for your lecture today. It is
Yeah, you're
very
very
interesting.
welcome.
I hope to see you again in another opportunity.
Okay. Thank you. Yeah, you're very
Okay.
welcome.
Okay.
Bye.
Okay. Maybe later we can have a photo session first with the audiences here. Maybe we
Photo
can.
session. how to do the
virtual
photo
photo
session?
session. Okay, in Zoom we can also have, maybe we can
Okay.
have our MC to help us, Mas Ivan.
All right, so we are going to do the
Yeah.
session,
For,
the photo
Dr.
session now.
Hongwei. Yeah, I think it's better to do it now.
Okay.
Let-
Okay. To all guests and participants, we would like to ask you to turn on the camera first because we are going to have a virtual photo session together. Okay.
As for the screen, is it okay like that, Ivan, or
maybe for the
screen
screen, I think it's
home
better to
to unshare first? Is it?
yeah,
Yeah.
it is better to stop sharing the screen first. Maybe.
Stop sharing the
Yeah,
screen.
yeah.
Yeah. Okay, thank you very much. Okay, I
Okay.
think I see a lot of people in the first page here. Maybe you can take the photo first. Catherine, are you ready?
Okay, I'm ready. Okay, I'll count to
Okay, in
three.
the count of
Yeah. 1, 2, 3. Okay. Next page, please.
Okay, let's go to the next page. To the second page. Wow, there are a lot of people.
Okay, I'll count to
Okay.
3 again. 1, 2, 3. Okay, thank you.
Okay, I think we don't have more people turning on their camera on the third page, so I think we could continue this session.
Okay.
Okay.
Thank you, Ivan and Catherine. Okay, once again, thank you, Hongwei. Thank you, everyone who has participated in this visiting professor program. Thank you for being active in asking questions. And last but not least, from me, if there is any mistake during delivering or moderating this session, I would like to apologize and maybe see you again in another visiting professor program. Okay. Good afternoon.
Thank you. Yeah, thank you. Thank you for coming to the session. Okay, see you. Bye.
Bye. Oke. Terima kasih Mas Ivan. Saya kembalikan ya. Ditutup.
Okay. Boleh, Ibu. Okay, thank you very much, Dr. Hongwei, for the amazing lecture.
And thank you to Mrs. Trismiati and Cass for moderating the lecture.
Ladies and gentlemen, we have come to the end of today's event. On behalf of the Department of Informatics, we would like to extend our gratitude to everyone who has attended this meeting.
Especially to Professor T.S. Dr. Kamal Zuhairi bin Jamil and Dr. Hongwei, who has given us an amazing and interesting lecture. We hope to see you again in another visiting professor program held by Department of Informatics.
Before we part, please accept our deepest apologies if there were shortcomings while we host this event.
Thank you very much, and until we meet again.
We wish you all a great day. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Terima kasih Mas Ivan.
Terima kasih Mas Ivan. Mas Ivan,
Bye.
di ini aja Mas Ivan, dikontrak aja MC
Iya,
seumur hidup sama Mbak Catherine. Enggak seumur hidup, setahun.
Mbak Catherine nih.
Waduh.
Udah biar HM nggak kesusahan, Made nanti bingungan nyari orang lagi.
Emang Made ada nih? Made datang nggak nih?
Tahu kayaknya nggak ngerti.
Made ada nggak nih?